Hey guys, in this video I will be introducing the concept of molar ratios. Okay, what we've done so far in mole calculations, we've only been talking about a single amount of a material at a time. Okay, so my example I have here is if we're talking about an amount of oxygen, right, in this little balloon. So we can describe that amount with three different units. We could say it's 10 grams of oxygen, 0.313 moles of oxygen, or 1.881 times 10 to the 23rd molecules of oxygen. But all of this is the same amount of oxygen. We're just using different units to describe it. It's like saying you have $1 or you have 100 pennies. It's the same amount of money. We're just using a different unit to describe it. Okay, so far, those conversion charts that we've done, we've only talked about one amount at a time. Okay, all of these describe the same thing. What we're going to learn now is how to calculate what happens when we change this amount of oxygen in a chemical reaction. Okay, so quick recap on chemical reactions. These are kind of like recipes, right? The formulas in these reactions are our ingredients. Okay. Just like we have eggs in many different recipes when you're baking, oxygen is used in many different reactions. I have just one reaction that uses oxygen here. Okay? This is what happens when you burn propane. 1 C3H8 plus 5 O2 yields 3 CO2 and 4 H2O. It's a combustion reaction for burning propane. You see that we have oxygen on the reactant side of our equation here. Right. The coefficients, those numbers that are underlined, right, they're the amount of each ingredient that we have present. Right? So, the cool thing about these reactions is that we can use them to predict how much products we're going to create when we have this reaction take place. Right? So, if I have that 10 grams of oxygen we were talking about, and I want to know how much H2O is present after the reaction takes place, I can figure that out using dimensional analysis. The only problem is, so far, we haven't done any calculation like that, and this chart that we have can't help us go from grams of oxygen to grams of H2O. We're going to need molar ratios to make that happen. Okay? So, to get from grams of O2 to grams of H2O, we need to find a molar ratio that can compare oxygen to H2O. Right? So to find a molar ratio like this, it's actually the simplest conversion factor we've done so far. All you need to do is look at your balanced chemical equation, find where your formulas are in this equation, right, and set them equal to each other. In this chemical equation, we need 5 moles of oxygen, and after the reaction takes place, we'll have 4 moles of H2O. So to make this conversion factor, all I'm going to do is add a unit in here, so 5 moles O2, and I'm going to set it equal to my coefficient from the other side, 4 moles H2O. Okay. And that's it. That is our conversion factor we can use to switch from moles of O2 to moles of H2O. It really is that simple. But if you're looking, yes, this is in grams and this is in grams, so there's a couple more steps here. In the next video, I'll show you how to do this whole process together. But this is our basic way to find molar ratios.